Okay, I'm going to do section 4.4, number 13. Our characteristic equation here is r squared minus r plus 9. We would have r equals negative 1, which is 1 plus or minus square root of 1 squared minus 4 times 9 all over 2a, which is 1 plus or minus 1 minus 36 is the square root of 35 all over 2. So in any case, neither of these have a 3 in it, so r is not equal to 3, so no resonance. So what we're going to have for our homogeneous solution is just, let's see, it would be e to the negative 1/2, no, wait, just plug in the r, e to the 1/2 t, e to the t over 2 times cosine of square root of 35 over 2t plus e to the t over 2 times the sine of square root of 35t over 2. But for our particular solution, we're going to have a something based on this 3 sine 3t. It's going to be, let's call it a times, for more generality, we would need a C1 and a C2 in there. Okay, but for our particular solution, we're going to have the form a times cosine 3t plus b times sine 3t. We need to determine what this a and this b is. And in order to do that, we need to find out what y prime and y double prime are. So y prime is going to be, I'm going to switch the order of these things. So it's, or when I take the derivative of cosine, I get negative 3a sine 3t. And when I take the derivative of the sine, I'm going to get positive 3b cosine 3t. When I take the second derivative, I'm going to take, again, switch, so this one's going to be 9b sine 3t, and this one's going to come over here and be negative 9, wait, this is negative 9b sine 3t, and this one is also negative 9a cosine 3t. So this one changes to negative, this one stays negative. Now we're going to take a sum of one of these minus one of these plus 9 of these, and so one here, minus, plus, and let's see, 9 of these. I'm sorry, I have this backwards. We're going to have 9 of these, and then minus 1 of these, and plus 1 of these. So this will be multiplied by 1, this will be multiplied by negative 1, and this will be multiplied by 9. And the sum is going to be 3 sine 3t. And the sum over here is going to be 0 cosine 3t plus 3 sine 3t. So this leads to 9a minus 3b minus 9a. So 9a minus 9a minus 3b equals 0. And this one over here leads to 9b plus 3a minus 9b equals 3. So at this point I can see that negative 3b equals 0, which means that b equals 0. And so this would be 3a equals 3, which means that a equals 1. That means that our particular solution equals a cosine 3t plus b sine 3t is, in this case, just cosine 3t. We can verify that y prime is negative 3 sine 3t, and the y double prime is negative 9 cosine 3t. So y double prime, y prime, so negative 9 cosine 3t minus negative 3 sine 3t plus 9 times y, which is cosine 3t, is equal to positive 3 sine 3t. Now, what the matrices do is basically produce information like this and kind of separate these coefficients away from these, and it involves a little bit less writing is basically what it does. So if I have say y sub p, y prime sub p, and y double prime sub p, the particular solutions, equals for y sub p it was a times cosine 3t plus b times sine 3t. Let me go ahead and separate those a little bit. You'll see why in a moment. Now when I take the derivative of cosine 3t, I would get negative 3a of a cosine t. I would get negative 3a cosine 3t, and the derivative of b sine 3t is b cosine, or 3b cosine 3t. I'll go a little bit more into that in a moment, but the derivative of 3b cosine 3t is negative 9b sine 3t, and the derivative of negative 3a sine 3t is negative 9a cosine 3t. And now we want to represent our equation here. So let's, oops. So what I'm going to do is put a 1, negative 1, 9 here to represent y double prime minus y prime plus 9y. Same thing here, 1, negative 1, 9. And then over here with the 3 sine 3t, I'll be putting, we'll have 0, 3 times cosine 3t sine 3t. Now this becomes a matrix multiplication, where we take the matrix multiplication of these is negative 9a minus 3b plus 9a, and that's equal to that 0 there. And then you'll take the negative 9b minus plus 3a plus 9b equals 3 to get the equation for those. There's one other thing that you might find helpful to do with matrices is finding the derivative of y sub p. The first column of y sub p can be found with this and this, and so I will write that as y sub p equals ab times cosine 3t, or cosine omega t, let's call it, and sine omega t. Y double prime, or y sub p prime is going to pop out an internal matrix. Derivative of cosine omega t is negative omega sine omega t, and the derivative of sine omega t is omega times cosine omega t. You fill out the zeros in other places, and y sub p double prime is a b times, we would have negative omega squared here and negative omega squared here, after you square this matrix, of course. So I kind of skipped a step there, but it still has the cosine omega t and sine omega t. So then, if you're setting up an expression, say y sub p prime, y sub p double prime, you'll have this a and b up at the top times cosine omega t sine omega t. Then you multiply this through, it would be b omega and negative a omega. Just to make sure you understand, the b omega comes from there. Then we have the y prime omega, which is this, negative a omega squared. And the next column is this a times 0 plus b times negative omega squared, which is negative b omega squared. Now, are the matrices necessary? Almost definitely not in this particular problem. A lot of people would be able to just kind of look at that and by inspection figure out that taking the negative of the derivative of sine 3t would give you cosine 3t, and perhaps, well, I don't know if they'd see it or not. But this is a peculiarly contrived problem. If this had been, for instance, 3 sine 3t plus 2 cosine 3t, then this equation here, it still would have been 9a minus 3b plus 9a, but we would have just replaced that 0 with a 2. And then it might even be worthwhile to set up another matrix here, where we have a, b, functions of a, b equals 2, 3. So in this one, negative 3b equals 2, and 3a, I guess these both cancel out, so that's convenient too. 3 times a. So this is an unusually simple problem too for that. So this would have an answer of a equals negative 2/3 and b equals 1. So your answer would be, particular solution would be negative 2/3 cosine 3t plus sine 3t. And that would end up giving you the 3 sine 3t plus 2 cosine 3t. Actually, now that I've set it up, I think this is backwards. It would be a equals, or it'd be 3a equals 3. So a is equal to 1, and b is equal to negative 2/3. So you would end up with y sub p being cosine 3t minus 2/3 sine 3t.